Today's video will explain the UML class diagram. Hello, I'm James Helfrich. Oftentimes we want to work the classes, but don't want to get bogged down in the detail of the syntax of the classes. The UML class diagram is such a tool to facilitate that. This video will explain how we use a UML class diagram and relate it to the actual class syntax in many popular programming languages. The following code defines a class representing a GPA. Now, first we'll start in C++, where I say class GPA, curly braces, private, public, and so on. And then I'll do the same thing in Python, except, well, the syntax is quite different. Constructors are different. The way you define functions are different. Member variables are different. And then Java is, well, completely different as well. Wouldn't it be great if we could have a language independent way of describing the class without getting bogged down in complex and unimportant syntax details? And this is what the class diagram is designed to do. Now, every class diagram starts with a class name, and this is always the first row in the class diagram table. In this case, our class name is GPA. The second row in the class diagram table is for attributes, and I have one attribute, which is a GPA. The third row in the class diagram is reserved for methods, and I have a constructor, an isValid method, and a getter and a setter. Public attributes and methods use the plus access modifier, and the access modifier goes immediately before the attribute and the method. So the constructor, the getter, and the setter are public methods. Private attributes and methods use the minus access operator, and the GPA member variable is private, and the isValid method is private. And one can optionally provide the data types of the attributes. For an example, GPA is going to be of type float, and method parameters and return times can also be provided as needed. It's not required. So my isValid is going to return a Boolean, my get is going to return a float, and my set is going to take an attribute, which is going to be GPA. So let's compare and contrast a class diagram with equivalent code in C++. So the class name, GPA, is the first row of the class table, and we say class GPA in C++. The attribute, GPA, float, is going to correspond to double GPA in C++, and the minus is going to correspond to private colon. So the syntax is completely different, but the meaning is a one-to-one mapping. Now, with constructors, I have a method with the same name as the class in C++, and I don't have a return type. In this case, I'm going to have two different constructors, a default and a non-default constructor. Now, I can choose to show those differences in the class diagram or not. The level of detail you put in the class diagram is up to you. Notice how I have a private method isValid returns a Boolean. And so you represent Boolean in C++ with bool. And then, of course, isValid is a constant method. It's not going to change the attributes. And I don't really have a way to express that in a class diagram. So oftentimes there are some language constructs which do not map to the class diagram, or perhaps even vice versa. And I have two public methods, the getters and setters. And once again, the getter is a constant method in C++, but I don't have the ability to express that in the class diagram. And I'm choosing to represent my float as a double in C++, whereas in the class diagram, I could either say it's a double, or I could just say, look, it's some floating point time, and I'll worry about those implementation details later. And finally, of course, notice that in my C++, I have a comment, and class diagrams don't have comments. Now, the same exact code in Python is going to look quite a bit different. And then once again, the way I define the class is different. I have the colon, whereas in C++, I have the curly braces. And this is kind of weird. In Python, we don't actually declare attributes. We just kind of use them and they pop into existence. And so since in my constructor, I say self.gpa, then it kind of pops into existence. And unfortunately, I don't get to specify the data type. Now, constructors are done kind of weird in Python. I have the underscore underscore init underscore underscore method, which is quite different than C++. And so these syntactic details are going to be very different between languages. But with the class diagram, I don't have to worry about those details. Now, there's no real true private methods in Python, but if we put the underscore in front of it, that's an indicator that this is private or protected. And then my getters and setters, of course. Now, observe that my getter in the class diagram does not have a parameter, but in Python, every method has a parameter, and that parameter is self. And I have to specify that explicitly. And once again, this is some of the syntax difference between Python and other languages. Now let's do one more example here. In Java, then the way that I declare the class is quite different than before. I have to say this class itself is public and I have the curly braces. I do get to specify the attribute data type, double GPA, just like I did in C++, but I have to explicitly say this attribute is private as opposed to having the private access modifier applied to a range of attributes or methods like we do in C++. So the syntax is quite different. The constructor looks very much like it does in C++, different than it looked in Python. The data type Boolean is actually spelled out Boolean in Java, where it's just bool in C++. And of course, my getters and setters look very similar like they did before. As you can imagine, there's quite a bit more about class diagrams than this, and you'll learn about those details in the class diagram chapter of the software design textbook.